Students, last time we have concluded with the limits, speeds, tolerances. Then we have seen the gauges, design of gauges, the IS 919 system for the designation of hole and the shock basis systems. Next unit, that is unit number 5, is on measurement, that is linear measurement and angular measurement. The first part of this unit number 5 is comparators. So as the name indicates, comparators, what it means? It only compares, the comparator which compares the unknown dimension with the standard dimension or the master dimension, the basic size. So if we want to inspect the parts, some mass production is going on and we are inspecting the parts, we are checking the dimension. So it once it is set to the master reading, that is the basic size, then it can detect the variation in the various parts from the basic size. So that are the comparators. So it compares the unknown dimensions of a part with some standard readings or the basic size, we can say, and the dimensional variations from the basic size that are amplified or magnified and measured. The advantage of comparator is that skill required is very less, because it is just to check the difference between the basic size and the dimension of that part. So there are 4-5 types of comparators we are going to see in our syllabus. First one is mechanical comparator, then there is electrical comparator, optical comparator. Optical comparators are always in combination with mechanical. That further that value is amplified or say with the help of some optical setup, and that we can say we can have better reading. Then pneumatic comparators are there, their working principles, their operations and their applications. So these we are going to see in the first part. Then the next is angular measurement, that is vernier, then optical, bevel protector. All these are what? The instruments used for measuring the angles. Then there is thread measurement, screw thread limits, then limit gauging for screw threads. So these are nothing but the sort of gauges with the help of which we can get the dimensions of the parts to be checked, and we can compare it with readily compare it with the master dimension, that is the basic size. So whether it is within the acceptable limits or not, so that we can check it very readily with the help of these instruments. So first we will start with the comparators. Now what is comparator? That I have already told you that comparator is an instrument which compares the unknown dimension with the standard dimension. This is the simple definition of comparator. That comparator is a robust design, because all the time we will be using that comparator to check the parts. So it identifies the difference between the test workpiece and the master workpiece. So we have got the basic size, means as per the specifications given in the design, we have got the basic size, and whether that part or that workpiece is produced to that basic size, how much variation is there, whether that variation is within the acceptable limits or not. This we can check with the help of comparators. Comparator is a device which picks up small variation in dimensions, magnifies it and displays it by using indicating devices. So what it does, it picks the small variations between the workpiece to be tested, dimension of the workpiece to be tested, and the basic size, that is the standard dimension. So these variations are picked with the help of comparator, then that magnifies it and it converts that into some reading, and it displays it on the indicator, or we can say any. So there are so many types of comparators are there, so it gives you the reading. So we can set that particular comparator to the basic size as 0, and then whether it have certain deflection between after checking the workpiece, then that can be recorded. Then there is classification of comparators, as already I have told you: mechanical comparators, then pneumatic comparators, optical comparators, and electrical comparators. Now all these four types, they are having their pros and cons, means advantages and disadvantages. So where we are using these comparators? So comparators we are using in mass production, where there some number of identical parts are produced, where components are to be checked at very fast rate. Then the inspection gauges are to be checked, or the working gauges are to be checked, and they are to be correlated. So whether some variation is there or not, that we can check. Then if we are purchasing the gauges, newly purchased gauges, that can be checked with the help of comparators. It can be attached to some machines also. Some machining is going on, and that particular comparator can be attached to that machine. Whether that workpiece is produced to the standard size or not, that we can get it readily available with the help of comparator. Or in selective assembly parts, we have seen selective assembly, we are grouping the produced workpieces. So say oversized holes are grouped and oversized shafts are grouped. So oversized shafts are grouped with the oversized holes. Basic size shafts are grouped with basic size holes, and undersized shafts are grouped with undersized holes. So that is what is selective assembly. So we are grading the parts produced as oversized, basic size, and undersized, and that we can have the required assembly with the help of that. So in that selective assembly, the grading of the parts in the three or more groups can be done very easily with the help of comparators. Then this mechanical comparator, it works on the gears, pinion, linkages, levers, springs. All these are what? The parts which are forming an assembly of a comparator. So whatever say quantity is to be measured, then that is to be can be transferred into some other quantity, or we can say a probe or a say plunger is coming in contact with a workpiece, then how much it is moving upward and downward. So upward and downward movement of that plunger, it can be transferred as the moment of the indicator on the dial. So these things can be done with the help of gears, pinion, rack and pinion, or levers or springs simply. So this, as we can see in just our gauges also, in pressure gauge, what happens? The air pressure, it when we are measuring the air pressure, it expands the tube inside, Bourdon tube pressure gauge such as, and that will expand the spring inside and will lift the indicator from 0 to some quantity over a dial indicator. So we get the pressure inside. So this type of things can be used in mechanical comparator. Then in pneumatic comparator, the high pressure air is used, valves are used. So this we'll see in detail. Optical comparator, we are using lenses, mirrors, and these optical comparators, light sources are also there. Optical comparators are always used with the combination with the mechanical comparator, mechanical means, or we can say basic mechanism is there, and that value can be amplified with the help of some optical means. Then there is electrical comparator, where we can have the step down transformers, uh, with the help of which we can get the readings. But it requires the source, that electric source or the AC source. Uh, so that's why it is having certain limitations. So first we'll see the mechanical comparators, the advantages of mechanical comparator. These are usually cheaper, or we can say economical to for the use in comparison to the other devices. These do not require any external supply of energy such as electricity or air pressure. It doesn't require anything. So we can say that it is economical for use. Then usually mechanical comparators have linear scale, which is easily understood, or no skill is required, or that worker, maybe an unskilled worker, can have the idea about whether the part is produced to the required dimension or not very easily. These are robust and we can say compact and very easy to handle. Then they are portable also. They can be carried from one place to another place, as it is not requiring any sort of external energy. But there are certain disadvantages of mechanical comparators. uh, as there are so many parts moving inside, there is a mechanism. That mechanism may consist of a gear train, a spring, a dial indicator, or a lever. So many things can be there in that assembly, and because of this there will be friction whenever some mechanical or some mechanism is moving. Some parts are moving with respect to one another, it creates the friction, and hence we can say that in this case the accuracy may be sometimes disturbed because of the friction in the moving parts. So this is first disadvantage of mechanical comparator. So accuracy is less, we can say, in the uh, mechanical comparator. It is sensitive to vibration, as the mechanism has more inertia. It may cause that instrument to be sensitive to the vibration. Then this range of this instrument is limited, as it moves, that pointer moves over a fixed scale only. So these are some disadvantages of mechanical comparator. Then the advantages of optical comparator we will see. The parts here are very small in number, and hence we can say that they are possessing more accuracy or high accuracy. Then we can have very high magnification. We can magnify the small value into some large quantity, and they are weightless, so not bulky. So we can move that, we can handle that very easily. Then there are certain disadvantages also. There are electrical supply is necessary for the as we are using the light rays, and to produce that some electrical source is required. The apparatus is large, sometimes very expensive, and whenever we are using the optical instrument, we require a dark room. So it can be a separate setup to be used for the comparator, like optical comparator. So these are certain disadvantages, and it cannot be used for the mass production, or we can say continuously we cannot use optical comparators, as it requires the dark room and the setup and all these things. So all the time it is not possible to check the dimensions continuously. Then there are electrical comparators. it has got also it has got very small number of moving parts, so accuracy is high, magnification is also high, so we can magnify to any limit. Then it is the pointer is very light, and we can say that it is not also the sensitive to vibration, as the moving parts are very less, but it requires the uh, electric source. That is what is the disadvantage, that external energy or agency is required. That is what is the electrical power supply. Then it may sometimes if we are continuously using that, it may heat the coils in the measuring unit, and they are more expensive, so as compared to the mechanical comparators. So these are the disadvantages of electrical comparator. And then the last one is pneumatic comparator. So here it is not coming in contact with the workpiece, so wear and tear will be very less. So very small number of moving parts are there, and hence we can say there is less friction. Vibrations will be less as inertia is less. Measuring pressure is very small, so only a jet of air can be sufficient, and we can have it is possible to have higher magnification also. So these are the advantages of the pneumatic comparators. Then the disadvantages here is it requires the bigger setup. We can say the equipment such as pressure regulators. The scale generally is not uniform here. Then it requires some indicating devices also, and it is not say very easy to move from one side, one point to another point, because it may require a compressor, because the air pressure is to be applied. So hence it is not that convenient as the mechanical comparators. So these are the four type of comparators we are having in our syllabus. So these are the characteristics of a good comparator. Obviously, first one is compact. So if the design of the comparator is compact, it will be very easy to handle, and anybody can handle that. Anywhere we can move that. So good comparator should possess a compact design. It obviously will lead to what? Handling easier. Then quick response should be there, so that the time consumed to check the dimension will be less, so result should be displayed quickly. It should be reliable when we are using it. The readings what we are getting it should be accurate and should be reliable. Then it should not affected by the environmental conditions such as heat or cold, or we can say humidity. So these conditions should not affect the comparator. So these are the qualities possessed by a ideal comparator. It should possess all these qualities. So a good comparator should have these characteristics. Should be less in weight. Obviously, handling of that from one place to another place will be easier. It should be cheaper, so economical point of view we are using it. Then easily available in the market, sensitive as per the requirement. So which dimension it is to be checked, and it should give you the result readily, very efficiently and accurately, and very precisely. All the time it should produce the same reading. So that's why it should possess the sensitivity. Then it should be robust in design. Robust means it should not get deteriorated by the use. So it should be robust in design. So over a period of time, over a longer period of time we are using, it should not change its characteristics. then less maintenance should be there. So over a period of time, if we are using it maintenance wise, then it should be easy to maintain and cheaper to maintain. So also maintenance should be less. Then hard contact point for long life. So because this comparator is the probe or the plunger is coming in contact with the workpiece, so that probe should be hard, so that there should not be any wear and tear easily. So that is required for the long life of that comparator. Then free from backlash and wear. So this faults should not be there. As I have told you, it should be hard. It should have hard contact point. So this backlash or wear should not be there. So these are the properties, or we can say the characteristics a good comparator should possess. Uh, then next is the mechanical comparator we are going to see. There are three types of mechanical comparator generally in use. First property of this mechanical comparator is self-control. So there is no external agency or any sort of energy we are using. No air pressure is used, no electrical supply is used, no say any sort of light source for the radiation is used. So it is self-controlled. So only it is having a equipment, a compact design, and we can say we can very easily handle it. There no power or other form of energy is required. So as I have already told you, mechanical comparator is just an assembly of various linkages. It is a mechanism. It converts one moment into another, and all this assembly is assembled in a enclosure, and that is what is a comparator. So no power and any other form of energy is required. Moment is due to the difference between standard and the actual dimension. So we are comparing what? The actual dimension of the workpiece and the standard dimension. So it is set to 0 at standard dimension, and any deflection of the indicator, if there, it can be on either side. So that will be because of the difference between the actual dimension and the basic dimension, or we can say the standard dimension. Then magnification is by means of levers, gear trains, and combination of this. So that moment of that probe or that particular plunger can be magnified. The moment can be magnified with the help of certain mechanism, and that mechanism can be a gear train, can be springs, can be lever. So it is just a mechanical assembly of various parts or links which converts that motion into some another motion, and that gives you the comparison between standard reading or standard and the actual dimension. Then these are the four types of mechanical comparator we are going to see. First is dial indicator, very simple and very compact type of design we are having dial indicator. It can be attached to the machine also, that we'll see in detail. Then Johnson's microcrater is there. It is designed by a scientist named as Johnson, C.F. Johansson. So that's why it is known as Johansson microcrater. Then sigma comparator is there, and mechanical optical comparator is there. So it is combination of mechanical plus optical. So all these comparators, these mechanical comparators, they are having the same principle of working, where we can say the moment of that particular probe or that plunger is transferred by certain mechanism. The mechanism can be different in all these four. Dial indicator is having separate mechanism, Johansson's microcrater is having separate mechanism, sigma comparator is having certain different mechanism, Mechanical optical comparator can have a different mechanism, but the basic principle is moment of that probe, because of the variation in the dimension, is converted into the moment of the indicator on the die, and that gives you the difference between the actual size, actual dimension, and the standard dimension. So all these four types of comparators we are going to see as mechanical comparator. The last one, mechanical optical, is uh, mechanical means, or with the help of certain mechanism we are getting the variation, and then that quantity is further amplified, magnified by the optical means, and that's why it is combination of these two, mechanical and optical comparator. So first in that is dial indicator. So this we'll see in detail in the next video.